Hello everyone. In this lecture, we're going to look at data entities and modularization. So let's get started. So what are the objectives of this talk and this lecture? It's going to be ERD, entity relationship diagrams and class diagrams. And then we're going to look at the definition of the entities, attributes. We're going to do a recap on them, and then we're going to see the relationship between entities and relationship properties and also cardinality. So we're going to consider modularization and incorporating this into the design process of the database. So let's get started. From here, from an entity. What is entity relationship modeling and diagram? And what are the class diagram? What are the entities and attributes? So basically, we assume that behind the entity relationship modeling or diagram is an organization data structure, which can be modeled with the use of just three distinct objects, which those objects are entity type, relationship, and attribute. First, let's look at entity. So an entity type is a type of thing which is able to represent an independent existence and on which the organization may wish to hold data. This is the key characteristic of an entity type. For instance, the entity type employee, which all of you are familiar with this type of employee entity, is a type of things on which a payroll department may wish to keep data. Which type of data? Actually, it could be the employee number and date of birth. The entity type is an abstract concept of which there are particular entity occurrences. It is also can be held within the data structure. An example for this is gonna be an entity as an employee in one department. The name of that employee can be anything. So here we assume that is John. So we look at this entity, but we look at the different relationship and different attributes. For example, we can say he is father of his son or his daughter. So entity type may also be assumed as a document which explaining something else like order. So, and for example, some other entity type could be academic courses and so on. So for you, we have one example in here, which right now you need to be able to tell me which are entities. So if you cannot, then you need to be able to answer this after a few slides. So as we said, entity relationship model is gonna describe something which is required for an organization or business. So we need to implement our design and our plan based on the entity relationship model. And then we're gonna implement of any type of DBMS or even a file system. So let's look at this entity relationship model. As we said, we do have three objects within the ERDs, entity relationship, entity attribute and relationship. We do have another object which are not the main focus of this lecture, and because actually they are not that important and fundamental as a basic object for defining an entity relationship model. So what we can say about attributes? So the entity type that are deemed applicable to an organization also have attributes. This can be taught as properties. So the entity type, for example, employee, has the attributes of name, employee number, date of birth, and more information like address and so on. So for a particular occurrence of the type employee, so let's say John, our previous example, this attribute have the value of some other name, like, so like the full name of this person, and like John Becker, and his address, and his date of birth, and his phone number, and so on. So here you can see that we do have two entities. So one of those entities that you saw could be airport and flight. For airports, we do have name and country, and for flight, we do have these attributes. So if we look at the next slide, we can see more attributes of different types. So for example, we do have simple, atomic, composite, single valued, multi-valued, and drive attributes. So there are some examples for this kind of attributes. For example, atomic or single can be age is just one definition of that. So one example of that. And the name could be composite because it can be several different parts inside a name. And single valued can be height. So, and multi-valued can be field, gender. And the drive attributes can be wages, salary, and hours work, or hourly rate. So we do have the attributes rules within a data entity relationship model. So what are those rules? We need to respect something in here, which this implies a missing entity in here. For example, we say we are not allowed to have a redundant group, or we are not allowed to have null value, and so on. So let's look at the last and the third fundamental object for entity relationship diagram, which is relationship. What is relationship? How we can define it? The entity type applicable to organization can bear some relationship to one another. So, for example, look at this example. So the entity type airport will bear some relationship to the entity type flight. And another example could be the entity type employee instead of airport will bear some relationship to the entity type department instead of flight. So airport, flight, employee, department. Because the structure of the organization requires each employee to be a member of a department. So right now, you can understand that when we say something about relationship, there are rules that we need to respect. For each organization, each system, this rule might be different. And we need to understand them. If we don't know and we are not sure and it's not given, then we can decide based on the best of our judgment. So not all entity type will bear relationship to other entity type. The entity type, for example, order will not have any special relationship with employee. For instance, the relationship between an employee and the department or airport and flight which shows so for example for the flight, say a member will be called membership relationship because a flight can be a member of the airport, and so an employee can be a member of a department. So we're going to look at this later in more detail, but for now we call such a relationship in reality, we call it a relationship with a predefined rules. So let's look at the next important concept. You can see some numbers in here, 1 and 0s. So what are these numbers? Have you ever think of them? So actually these numbers are representing something very important. They are representing the cardinality. So we could say there is always one airport, 2 more flights. Because we do have 1 too many. This syntax, this symbol and notation gonna represent many. So there is a 1 to many relationship. One airport departs from many flights. So there may be 0 or more flights for each airport as well. So there are different types of interpretation for that. So let's look at the more definition of the relationship. How 2 or more entity types are linked to one another gonna be define the relationship. So, and when we want to understand the connection, we need to have some extra data that's showing that some of the entity are belong to someone else or there are some rules among them. So if the link adds extra data that does not belong to just one of the entities, the link itself may also be an entity. So here you can see there are some type of improving of the design plan. So actually, when we do have something like that, we want to add some link, some connection. We want to consider some more connection. However, this link or connection itself may represent an entity. Then it's better to consider an entity instead of just writing in a relationship what is the rule. So later on, you can understand that by understanding this type of relationship, you would be able to have a very good and efficient database because you are applying normalization to the data. So I have a good example for you from your book. So here are examples of the relationship types. What are the relationship types? Employee is connected to department. Membership. So we're gonna say which type of relationship. So here you can see that so we have different entity in this side and another in the other side. And we're going to say again, there is a membership relationship between these entities. So here we say we do have a one-to-n or one-to-many relationship. It can be understood as a stating that each department has n employees as a member, and each employee is a member of one department. A representation of the occurrences can be seen in the next ones. So let's look at the next. So in here, the relationship is still one-to-many. So even though a store has only one member, but the restriction on the relationship is that each employee can be a member of at most one department. If departments can exist without having any employees as a members, so then this may be as shown in the other one. So here we can see when we apply other one. So we say if a department actually so can exist without having any employees, then we're gonna represent the relationship by using this notation, so dashed. But in here we had other rule and we say should be at least one, right? So let's look at the next one. So in here, so similarly, indexes that it is possible for an employee to exist who is not a member of any department. So, and then we do have many-to-many relationship. So we say supplier supplies item, and we call this M2M because we are not sure how many of suppliers can supply how many items. M2M relationship or many-to-many relationship actually is based on some assumption that each item that exists in the store for this particular example may be supplied by many suppliers, and each supplier may supply many items. This is said to be a M2N relationship or many-to-many relationship. So let's look at other type of relationship, like one-to-one relationship. So if you consider, first let's look at the G and H. So in here we do have one-to-one relationship. Why? Because in most societies, each man is allowed to be married to at most one woman, and each woman may be married to at most one man. So there is one-to-one relationship, man, marriage, woman. So in terms of we say a man marry at most one woman, and a woman marry at most one man. Another example is represented in here. So this is important actually. So let's look at this. So in here, so we can see that we do have some instances in here. So we say John and Jane, they don't have any relationship because it could be 0, as you see dashed line. So, but George married Mary. So there is just one-to-one relationship. Marx marries Carol, and there is one-to-one. Simon is on his own and doesn't have any woman to marry. So let's look at the next one. We do have some other type of notation. If you see, we have a dash and then a circle in here and then many. So we say involuted relationship. So what we call this? So relationship may occasionally be involuted. So this means that an example of an entity type is related to another example of the same entity type. So here you can see there is just one entity. So we are talking about just one entity. For instance, it's common for a part used in a later stage in a production process. So the components are made. So if another example could be, yes, a component are made up of components, right? Which are themselves made of components. So there is a circle in here, there is a cycle in here, and it's just one entity type. So this type of entity type involuted entity type or relationship, so implies that the parts and the composition follow the tree-like structure, which is represented in here. So part 1 is split between part 2 and part 3. Part 3 is related to part 4, 5, and 6. So this dotted line is necessary because there must be some part that will be basic. This is not composed themselves of the parts. So here I want to talk about the more interesting part, which is cardinality. So when we use cardinality actually gonna represent some rules, some information about the entity. In here, all employees have a job. So all employee, this represents an employee or an entity, which we say each object within this employee needs to have a job. It's not possible to any of them become jobless. So this is the rule which is defined. I know that in reality it could happen, but here is the employee because they are employees. Then they need to have a job. Then we're gonna say all employees have a job. No employee has more than one job. And not all jobs are held by an employee. So anyway, we can see lots of organization, they hire one person and at the beginning say, you need to just do this role, but at the end they say, oh, can you do that as well? And they're gonna add more, right? So here is example, but anyway, so this is the good rule, I like it. But as I said, sometimes it's not possible. And then the next one, and then the next one. So here we say that we provide something, we call this cardinality. We say, yeah, there are some relationship between them, and then the representing that is one to many, or one to one, or many to many, or many to one, right? So here is another example for you. So A is representing a relationship because saying the marriage and is 0, 1, 0, 1. And as we discussed earlier, B represent an attribute because we're gonna connect these two. We say they are related based on this because married status is gonna explain, describe something about employee, and date of birth is giving some information about the employee. Sorry. So, and the third one, telling you an entity type. So the entity type, we do have a marriage as an entity, and then we do have different type of the entity. So could be bride's name, bridegroom name, or date of ceremony. So here, to sum up whatever we learn, we have this full diagram for you to look at that. So we say customer has many order might have many items or no items, and so on. So here I just wanted to tell you something which is very useful for you for future, that you're going to use this entity relationship diagram to be able to map this entity relationship to a other structure, which is table. So here you say one entity can represent a table with different column, which can be different attributes. And for example, item can have item number, item description, and more attributes, which each attribute represents a field or a column in a table. So as I said, so you can convert this into another structure or vice versa. Here you do have some kind of data and information, and you want to be able to see a functional entity model. So you can convert this. You do have the entity, access, item, and supplier. So you do have two entities. And then you do have relationship, which is supplies. And then you do have some attributes for each entities. For example, for item, you do have item number. And for other one, you do have all of them. And action is retrieving. So here is another example that if you are familiar with this, I want you to look at this and just try to figure out whatever you've done in your previous use cases and whatever you understood about that. So you need to be able to provide an appropriate cardinality and relationship type, and you need to write down all of the rules, and then you need to be able to interpret those rules based on the cardinality and relationship type. So for example, here is an example for you. A customer can have many orders, 0 or many orders, and a product can have many or 0 order line. So many orders by a product, an order has 1 or many products. So here you can see another entity and tables. So based on the customer, we do have this table, which we do have these attributes, customer name, customer address, which are 2 attributes or 2 fields or 2 columns of customer table. And then we do have order, and here we do have product. Product does have another table with 2 columns or 2 attributes or 2 fields. So you can actually implement this relationship and this relational database by using Oracle, MySQL, SQL or SQL, and more actually software. So what is missing in here? Yes, keys. Keys enable instances, table rows to be retrieved. So we talk about attributes and column in a table, right? The appropriate data structure which organize our information, the useful information, is a table. So we talk about the attributes or columns. Right now we need to consider and we need to have some concern about the rows. Then we need to have some keys. So keys gonna organize our record, and we can distinguish different records or different rows based on the keys. Yeah, so here we can see that the key value allows the instance to be uniquely identified. As I said, you can have different records and you can distinguish between the records based on the key, defined key. For example, primary key, secondary key, and alternate key, composite key, and candidate key, and more. So what is primary key? Primary key, the attribute or combination of attributes that uniquely identifies the rows or record. So sometimes we say customer ID or customer number, for example, a student number, a student ID, but we need to make sure that this is unique. If it's not unique, you need to combine it with another attribute. So for example, sometimes you need to combine age, date of birth, and name to have different records and to be able to identify different records. Candidate key, one of the several keys that uniquely identifies the entity instance. So ID or name. So in here, we do have a student entity or table, and we do have different attributes which we consider this as candidate key. So here you can see the student ID is considered to be as a primary key. Candidate key is a combination of either first number and last number or a student ID. So candidate key shows as many as you want actually to be able to provide an identifier. For example, here we don't have any redundant in here, name. So it could be, for example, this one primary key, but we combine it with the last name to ensure that there is no redundant record. But we know that the student ID should be unique. So we can refer this as a candidate key or primary key. So it's not enough that we just say, all right, so I'm going to look at one table and I'm going to provide some keys. No. One entity has a relationship with many other entities. We need to be able to provide a very good communication way between tables or entities. For doing that, we need linking attributes. In the other files is called foreign keys. So for one-to-many relationship, the primary key from one to end is added as a foreign key in the many end. So for one-to-one, both ends may have the same primary key. So I'm going to give you an example in the next slide. So let's look at this. So what is the primary key in this table? Student ID. We underline always the primary key. What is the foreign key in this table? We don't know because it's related to other entity that we're going to consider to be able to say what is foreign key, right? So in the other table or entity, we do have course ID as a primary key because it's unique. And there is a relationship between these two tables, student and course. What else we do have in the course table? We do have course name, right? So, but we need to find something in common between these two tables or these two entities to be able to provide a relationship. So we can see that the course ID is the same as the course ID you can see in here. Sometimes you see some different writing of the course ID, for example, course number, but it still is the same values in here, so it doesn't matter. But the foreign key of one table should be a primary key of another table which is related to the first table. So let's look at another one. So here we want to see that, can we guess that what is the primary key and secondary key, and the foreign key in here? We need to find a similar object in here. We do have something CNAME in the order, and we do have PNAME, CNAME. Something is in common. Let's look at the example. If we have customer number in this particular order, then customer number in the customer table is a primary key. However, is a foreign key in another table, which is order. So here you can see another example. So keys and relationship in another example. So if you say in campus has one or many departments, you're right. If you say in a campus so a campus employs one or many lecturer, but is not zero, is not zero. So you can look at this and you need to be able to interpret this properly. So you can see, can you see the difference between this? We just change the direction. So this is a good example for you. So to look at that later. So modularization. What is the modularization, which is the last concept that we're going to go through, and I'm going to walk you through in this lecture. So divide and conquer. So for different abstract, we're going to look at the different type of design. We do have top-down design, we do have use case modeling, and we do have a conceptual database modeling. Modularization actually is when we split the problem into different jobs or tasks. So is when we have different module or procedure or function in a Java programming, different classes, we say we are doing modularization. So let's look at the first one. So when we talk about the different type of modularization, we want to go through different type of design. So top-down design. I'm gonna compare these two for you to explain them in a better way. A bottom-up approach to designing the data store involves extracting data fields as indicated on the previous lecture. So there are forms that the analyze that is using for analyzing data actually to specify the data content. So when I say that I'm gonna use top-down strategy, so is analysis or decomposition of a system component. So I'm gonna split a big problem into many small problems. So this facilitates planning and require complete understanding of the system. So how about the bottom up? However, sometimes we do need to use the reverse engineering or we need to go from the leaf to the root. So is the synthesis of the basic component to form larger subsystems. So actually we try to connect and get together every single component to be able to have a bigger picture. So, but what is the problem with this? This is difficult to formally plan this because it's more problem when you have a small components. You need to find how you can put them together, and there are lots of rules and regulations that you need to respect. But modern software developer combines both of them. So you can look at this in more detail, but you can have a good research on this subject because it's interesting. I want you go and Google it and then find a good resources to see which kind of software are doing this part or which part of a software are actually responsible to doing this part. So one way to break down software is component do things with data. So there is an example in here. So we do have a delivery notes, for example, in here. What we're gonna do, we're gonna use this breakdown strategy to be able to find a better solution. So actually we can say a system might be included of components and connectors. Because as I said, we need to know how we can put them together, how they are related. Is there any dependency between different components? Is it possible to relate this component to the other component, or I'm not allowed to do that? So then we need connectors. So actually, when we define a system, we need to consider both of components and connectors. So here you can see different visualization of this concept. We call this nested system, which is top-down design with three components we see in here. So component 1, yellow one, is a subsystem with three other components. Component 2, the green one, and 3 are subsystem, each with 4 components. So each of these components, as you see, they do have different number of components inside them. So cohesion, a measure of the internal strength of the model. So you can use it. So we say something is good in this term, which we mean that the subsystem has one function or purpose. So is coherent, is something unique. So, and is actually is well focused on a subsystem. Coupling is another concept which assesses the flow of the information between different modules, which this one actually indicates how independent a subsystem is. So as you remember, I told you for putting the all the components together, we need to be able to know the connector, and we need to be able to understand how they are dependent or independent. Here is the same. When we want to apply coupling, we need to be aware of these two concepts. So how independent a subsystem is based on these two. From the rest of the system, from another specific subsystem. So independency can be based on two different categories. So when we say good, we mean that should be low coupling. So if they are less independent, they gonna provide a better system, right? So disregard of the previous example, previous slide. So few interaction with others, because it's gonna make our life easier if we don't need to looking for all kind of independency and relationship among the components. So it's gonna be easier for us to figure out what we need to do and how we can connect them, right? So self-contained, as much as possible, we like this because it's easier. So a good system, rule of thumbs, yeah, high cohesion and low coupling. So it's obvious, we already talked about this. So rank of coupling, low to high, in here you can see which one is the lowest. So here we have low, which one is high. This one is the high and this one is the low. But you need to be able to say which one is the lowest. So in terms of the coupling, you need to find out the dependencies. How many dependencies you see in this component? How many you can see in here? How many you can see in here? Might be B. B has 2 links. A and C have 3. So B is lower. It's very easy. C is all one way. A is both way. So C is lower. So between A and C, we can see that from A, all of them are pointing to the second component. But in A, they are pointing into different. Actually, this is more complex component than this one because it's one direction arcs. In here is a complex two ways. So the same. You can look at the next one. If you look at this, can you tell me which one is the high and which one is the low cohesion? So if you look at this, obviously you need to say something. If it's high, is better. If it's low, is not good. So based on this, we already know that Y is the lowest. Why? Because there is less link among these components. And then X is the second lowest and Z is the highest because it got more internal links than X. So actually what we want to say in the high cohesion, we want to say that if there are some homogeneity inside one component between different components. So assume that we have a cluster. We have a cluster, different clusters, and these objects inside one cluster, they are related. They do have some relationship. So definitely it's better than the something that is totally different. 3 is totally different from 5 and from 4. So we don't want something like that. We want the coherent one. So yeah, so you can look at this example and you can answer that because it's based on the whatever we took so far. And then you need to be able to connect these two concepts and then go to the conclusion. So this kind of be your practice for the next week to provide it based on the different layer, different component, different independency and relationship about the internal component. So you need to be able to answer that. And then you need to provide an architecture of that based on those concepts. So we do have different layers. So here you can see 3 layers. We do have a storage, which is database and interface. And we do have domain model, and we do have the presentation in the higher level. Depending on different application, you can have a different type of domain model, either business or logic tier. So the software component, so as we say, the dependency and independency is gonna change. So if you look at this layer, for this layer, this type of components are high independencies, but are less in dependencies. And then domain model is something in the middle, and storage means this got more dependency than the presentation layer. So for the presentation layer, you have a GUI. For domain model, there is one example of rules of the games. And for a storage, database of Word. For this particular example, you can look at this link and to be able to just explain it and grasp the concept. So we do have the client and server model. So what are the client and server model are described in here. We actually in the distributed system, we do have some concepts about the server and client. So I'm sure that you know about the difference between these two concepts, client and servers. However, I'm gonna explain it. So basically, most modern information systems are constructed following the client-server model for the computation. This involves using desktop components as the clients, which make the request for the data or application from server. So these requests actually are passed to servers, which are the centralized stores of data. So client request, so here are the clients. They request some data from server, and then the server make a decision that is it possible to give them information or not. Client and server can run on the same or on different machine. So it's not always they are different and they should be located in the different physical location, no. So we use different platform for that. So typically there will be a number of servers, each dedicated to a particular task. So I can give you some example of that: file server, application server, database server, mail server, and print server can be some example of that. So, and more explanation of this can be based on the database model. So a database holds a very large number of records. As you know, a client computer user wants to make a number of requests for the data store, and then sometimes they require entire file of records, and the server needs to decide and provide a copy of those information and then send it to the client. So obviously, there are several factors which influence the balancing of resources between client and servers. Let's look at this. So, for example, I know that you might have a group project, and then you, in the different layer, you can have different example. So in the presentation layer, you're gonna have the robot control interface, and then in process model, you're gonna work on Java coding, and in the storage database, you're gonna look at the relational and the flat text files, right? Or Excel files. So that's it. That was everything that I wanted to cover in this lecture. Thank you very much for listening, and hope see you soon.